بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. In this video I'm going to provide all the steps to create and set up a Python package. So there are many people who create Python package but they don't go until the end. In this video I'm going to provide a comprehensive coverage about creating Python packages, not only the package and the module themselves, but also how to create the setup.py, what is the benefit of using a setup.py, how to upload a Python package into PyPI repository in order to reuse it later on or share it with others using pimp install. So this video is going to provide a comprehensive introduction to creating and setting up Python packages from zero to hero. So let's get started. In this video I'm going to use Visual Studio Code, which is one of the most popular integrated development environment. It's multi-purpose development environment, not really only for Python, but it has a lot of plugins that are customized for Python programming language. Of course, it's used for different programming languages like PHP, web application, and different other languages. So before starting, we need to create a workspace. So the workspace, this is where we're going to place all our packages or all our projects. So since I'm teaching the 316 course, I'm going to create CS316 workspace, and inside the workspace we are going to create the Python package. And basically a Python package is just a folder where we're going to create different Python scripts. So I'm going to create a package that is called 316 package, and inside this package we're going to create all our modules, Python modules or Python scripts. So since I am in Visual Studio Code, I can go to File, and then I will add the folder to the workspace. So the menu doesn't appear in this video, but you go to File and then add a folder into the workspace. So from Visual Studio Code, you're going to import this file. Okay, going here to add folder to workspace, and I'm going to import the whole workspace that contains also the Python package. And from here we can visualize it. So we have the 316 workspace and the 316 package, both are empty folders. So this is our workspace. We can even save it if we want to load it later on. We can save it as the 316 workspace. I'm going to put it in the coding space. So later on you can actually load it if you want. So you can open workspace from a file and load the whole configuration. If, for example, you will be adding a lot of other packages, you can just load them by loading the workspace. So inside the package, usually there is a special file that is called the init.py. So we will start by adding this one. And this file is very important. It has several usages, or purposes. Basically, it is used for package initialization. It marks this directory is considered as a package. Okay, if we define now, we're going to put it empty, but for advanced configurations, there could be some code like initialization code or import statement or exposing public APIs. There are different type of logic and code that we can put in init.py, but we can make it empty, and this is just needed to define a package as a package in Python. And apart from package initialization, it's used for code execution as a public interface, and also allows to perform sub-package management. We will talk about this in later courses. But let's start with a very basic. And afterwards, we can create code inside. So I'm going to create two Python scripts. So the very simple scripts. The first one, we're going to provide a Python module just defining some libraries without an execution, without the main function. So let me call it I'm going to call it general function.py. So I'm going to define general function. This is like a library I'm going to define. And in this example, we're going to use pandas. Okay, so I'm going to define these methods, calculate average. It will take a data frame. Don't worry if you don't know what is a data frame, but it's basically like a table where we're going to calculate the mean of the score of the students and of the grade or different scores. and another function that calculates the square root. So this is a very simple Python script. It imports the math function, it imports the pandas function as PD, here we use it as PD, and define very simple calculations of the square root and the averages. And then I'm going to define the main.py. It's another file. So just to populate this package with simple examples. And we are going to import, we're going to use this main function. So the main function here, it imports our Python module. So general function is a module that we can import. And here we have to calculate the average and calculate square. These are the two functions that were defined in our Python module. And here we're going to start with the data, convert it to a panda frame, and then calling the method calculate average for the math discipline, science discipline, and English discipline. And also calculating the square root, okay, by calling the method calculate square root. And now we have a Python package. We can start executing this package. Okay, so now we are able to execute the Python script or the Python main function, main.py. And for this, we're going to use, in my system, I have Python 3 installed. You may have in your system Python as Python 3, but in my case, I'm going to use Python 3 and then the name of the file, and it will be executed. Of course, here you will observe that you have an issue, is that pandas, there is no module that is called pandas. So pandas, as we already introduced in one of the lectures, it's a third-party library. It doesn't come installed with Python. So basically, we need to install this library manually. But imagine that you have a lot of libraries. Okay, it's not going to be efficient to install all these libraries manually like we do pip install pandas. So another way, which is much better, is to configure a setup.py, and this is one of the requirements of a professional Python package. So how to do that? We're going to create a file that is called setup.py, and one of the objectives of setup.py is also to define the dependency. And one of the objectives of setup.py is to define the dependencies and also some other characteristics of the Python package. So this is an example of setup.py. There is an import statement, and then we define the name of the package. For example, here it's 316 package, the name of the package, the author, the email of the author. Okay, for example, I'm going to put my email. So this is a description. Okay, it's like the metadata of the package. And you provide also a description of the package. This is for educational purposes for the 316 course. The long description is the Readme.md file. I'm going to show you how to make a Readme file. And the long description content type is text markdown. So this is going to be needed later on when you upload the package to PyPI. And if you have any GitHub repository, so in my case, I'm going to put it into my GitHub repository, github.com, and Iscuba 316 package. It's still not there, but we're going to put it also. And then you have some additional information called classifiers, which programming language is used, what is the license. You can choose this license if you are selling this or you want to make it for commercial purpose or as an open source. You can change the license. You can mention whether this is dependent on an operating system or not. What is the Python version that is required. So I'm going to put 3.9 here. And also here you define the dependencies. And you can see now we define pandas as one of the dependencies. And you can specify some constraints. For example, I want NumPy to be greater than 1.21/0 or so on. You can make it also, I think there is pandas 2 right now. So we can put it in this way. And you have the entry points. So using this way, okay, instead of making pip install pandas alone and NumPy alone and matplotlib alone, well, we can actually make pip install dot, of course, given that setup.py is defined in this directory. We are inside the C16 directory. And by the way, just before installing the packages, if you don't want to specify any constraint, you can just put, for example, NumPy or matplotlib or pandas like this. It's going to install the latest version. And if you want to have a very specific version, because sometimes there are dependencies issues, so you can actually set an exact version that will fit your requirement. So let me just install the latest version of all of these libraries, and then we can install all of them using pip install dot. So here you may have installed Python packages into your local. Yes. So now I am actually installing this inside the main global environment, and this is not recommended. So a better option is to create a virtual environment, and this is what we're going to do before installing dependencies. So I don't want to select this global virtual environment, which is the Python 3 environment. So we'll put it without any change, and we're going to start creating a virtual environment right now. To create a virtual environment, there are two options. Either you created on using pip, okay, on the Python installation, or like in my case, I have installed Anaconda, which also offer flexible package management with Python. Let me start with the first option, okay, in order to create a Python virtual environment. So first of all, we need to make sure if venv is installed. So Python virtual environment is called venv, and you can create virtual environments that will be like a container for your package. Okay, so it's like you want to isolate your package, your project from other packages or other projects. So in this case, there will be no any conflict between the dependencies of project 1 and project 2. So the isolation into a virtual environment, this is a good practice that you need to do. And the first way is to use the pip virtual environment or the venv. So this will try to ensure whether, so I need to use Python 3, whether pip is installed. Okay, so all the requirements are satisfied in my case. And then in order to create a virtual environment, I'm going to use Python 3. So because now I'm using the physical installation of Python on my machine. So this is going to create a virtual environment, as you can see. So it created 316 venv. Okay, it was created here. It's not recommended to create the venv, so I'm going to remove it, and maybe we can create it into the workspace because we don't want to upload the venv. Okay, we can actually ignore it, but it's better to install it into another location. So let me install it into the workspace. So now it's created in the workspace. And then we need to activate, okay? We need to activate the workspace. So how to do that? We're going to activate the workspace by, I am in Linux. So in Linux, I am in Mac OS. So Mac OS and Linux, they actually use the same syntax, source, and then the name of the virtual environment /bin/activate. This is going to create, so it will now locate all the package into a virtual environment, 316 venv. So now I work in isolation. There is no conflict with other environments. And I can go back to my package, this 316 package, and then I can do pip install and install the dependencies. So, okay, there was one issue that there is no readme.md file. So let me fix this. I'm going to create it. I will put it empty now because here in the setup.py, it's pointing to a readme.md file. I can change this one if I want, like to something. This it contains the function utilities. This is like the long description, just to avoid the conflict. And later on, we will do the readme.md file. And now, pip install is going to install all the dependencies. Look, it's installing NumPy, the latest version, Pandas, the latest version, Matplotlib, the latest version, and Seaborn as the latest version. And you know, every library also have other dependencies that will be automatically downloaded. And now we're done. So I created a pip virtual environment. I have installed all these dependencies. And now if you look at my main function, which uses pandas, so before I was not able to execute it, and now I can do Python 3 main.py, and it's executed correctly as you observe. Okay, because now all the dependencies are installed. So if I go outside the virtual environment, I can use deactivate, and then if I want to try again Python 3, it's not executed. Okay, again, I need to go to the virtual environment, so I will go to the workspace, and then, so I need now to source the virtual environment again, going to the package, CS316 package, and now calling Python 3 main.py, and it will execute. So this is creating the virtual environment using venv. Another way, so I'm going now to do deactivate. If you have already installed Anaconda into your system, you can use the conda package manager, which also offer flexibility to the package management in Python. So in my case, Anaconda is already installed, and they can create a virtual environment instead of using Python.mvenv, I can use conda create -- name and the name of the virtual environment. Okay, so venv. It's not okay. I'm going to change the name conda just to make a differentiation. Now it is creating a conda virtual environment. So now I need to activate the workspace. I'm inside the virtual environment that is created by Anaconda. And now if we want to do pip install dot, so pip command is not available, so we can do conda install, and conda actually plays the same role of pip in a conda virtual environment, but you can also still use pip inside conda, but in this case you need to first install it. Okay, so we will install pip and all other dependencies. And now I can do pip install dot, and it's going to execute all the dependencies that are listed here. So it's downloading matplotlib, numpy, pandas in the same way as in the Python virtual environment, and that's pretty much it. Now I can go back, so I have my main.py function, main.py. So now I can use Python inside Python 3, because with pip it's going to install Python, and all is working as expected. Okay, so far we have introduced how to create a virtual environment either using pip or using Anaconda. And now we have a package that is up and running. So another important thing is also to have a professional Python package is to create a Readme file, and the Readme file should provide a documentation of your package. So let me give you an example. So the Readme file should contain relevant information about your package, and this is going to be later on used when you upload your package into the PyPI repository. So for example here, a definition of the package is an educational package designed to assist the students in this course, and the features it will allow numerical computation using NumPy, data manipulation using pandas, visualization using matplotlib. These are the requirements, okay, that were derived from the setup.py. It gives you information about the license. It gives you information about the creator of the package. Okay, so this is now we have a complete package that is up and running. Okay, you can use it on locally. And now the next step is to export this package into the PyPI repository so that you can share it with others and they can reuse it with the different libraries that are defined inside.